5 seconds and counting, and Apollo 13 is go. T-minus 20 seconds. T-minus 20 seconds and counting. 17, guidance release. 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence has started. 6, 5, 4, 3, 2, 1, 0. We have commit and we have liftoff at 2:13. The Saturn V building up to 7.6 million pounds of thrust, and it has cleared the tower.
Running out of time.
Mission control.
Here we go. It's a beauty. It's a...
April 17th, 1970. The Pacific Ocean. A tiny capsule floated in the water, scorched black by re-entry heat. Inside were 3 men who should have been dead. This is the story of Apollo 13. Most people know the Hollywood version, the movie, the drama. Houston, we've had a problem. But the real story? The actual engineering decisions? The minute-by-minute crisis management? The razor-thin margins between survival and death? That story is even more incredible. Welcome to Edge of Disaster. Apollo 13 was never supposed to be remarkable. It was NASA's third lunar landing attempt. After Apollo 11 made history and Apollo 12 proved it wasn't a fluke, 13 was supposed to be routine. Commander Jim Lovell, veteran of 3 previous space flights, cool under pressure, methodical. Fred Haise, lunar module pilot, first spaceflight, brilliant engineer. Jack Swigert, command module pilot, last-minute replacement for Ken Mattingly, who'd been exposed to measles. 3 men, 1 spacecraft, 250,000 miles from Earth. Launch was on April 11, 1970, 2:13 p.m. Houston time. The Saturn V rocket performed flawlessly. Stage separation, nominal. Translunar injection, perfect. Every system checked out. For the first 46 hours, Apollo 13 was textbook. Then, at 55 hours, 54 minutes, and 53 seconds into the mission, everything changed. Jack Swigert was performing a routine procedure, what NASA called a cryo-stir. Now, the spacecraft carried supercooled liquid oxygen and hydrogen in insulated tanks. These cryogenic fluids had a tendency to stratify. Warmer fluid rising, colder sinking. This created inaccurate sensor readings. The solution? Periodically stir the tanks with motorized fans. It had been done dozens of times on previous Apollo missions. Routine. Swigert flipped the switch. Panel 109. Switch position. Oxygen tank 2. Heaters and fans. On. 9 seconds later, the crew heard a bang. Not loud, not obviously catastrophic, just a bang, like a metal panel popping or a circuit breaker tripping. The master alarm sounded. Swigert looked at his instruments. Multiple warning lights. Haise, in the lunar module tunnel, felt the entire spacecraft shudder. Lovell, in the left seat, saw the attitude indicators tilting. The spacecraft was yawing. Something had just imparted angular momentum to a 60,000-pound vehicle, traveling at 25,000 miles per hour, through the vacuum of space. Then Lovell looked out the window, and he saw it. A massive cloud of gas, venting into space, crystallizing instantly in the sunlight, sparkling, beautiful, and terrifying, because that cloud was coming from their spacecraft. Swigert keyed the radio. Okay, Houston. We've had a problem here. 4 words, past tense. Not, we have a problem. We had a problem. Because whatever happened was already done. Mission Control responded immediately. This is Houston. Say again, please. Lovell took over, his voice calm, professional. Houston, we've had a problem. We've had a main B bus undervolt. In the next 90 seconds, telemetry flooded Mission Control. Oxygen tank 2 pressure, 0. Oxygen tank 2 quantity, 0. Fuel cell 2, offline. Fuel cell 1, voltage dropping. Main electrical bus, B, failing. And oxygen tank 1, slowly, steadily, leaking. You see, the command module Odyssey ran on fuel cells. These combined hydrogen and oxygen to produce electricity and water. No oxygen, no fuel cells, no fuel cells, no electricity, no electricity, no life support, no guidance, no communication. The spacecraft was dying, and they were 200,000 miles from Earth. In mission control, Flight Director Gene Kranz made a decision. Abort the landing, immediately. Apollo 13 would not go to the moon. But that was the easy decision. The hard question was, how do we get them home? The crew had 3 options. Option 1, direct abort, fire the service module engine, flip the spacecraft around, burn back toward Earth. Problem? They didn't know if the service module engine still worked. The explosion came from the service module. Firing that engine might destroy what was left of the spacecraft. Too risky. Option 2. Abort using the lunar module engine. The LM, callsign Aquarius, was attached to the nose of Odyssey. It had its own engine, its own fuel, its own power. But Aquarius was designed to land 2 men on the moon for 40 hours, not keep 3 men alive for 4 days. Still, it was safer than option 1. Option 3, continue to the moon. Use lunar gravity to slingshot back to Earth. Free return trajectory. Longer. 4 days instead of 2. But it required no risky engine burns immediately. They could assess, plan, conserve. Kranz chose option 3, free return. Meanwhile, in the spacecraft, Lovell floated to the window, the one that faced the service module. He'd been avoiding looking, but he had to know. He looked. An entire panel was gone. Panel 4. 13 feet long, just missing, ripped away. The interior of the service module was exposed to space. Wiring, plumbing, tanks, all visible, all damaged. Lovell radioed Houston. It looks to me, looking out the hatch, that we are venting something. We are venting something out into space. He paused. It's a gas of some sort. Engineer Cy Liebergott, watching the telemetry, knew what it was. Oxygen. From Tank 1. They were losing their last oxygen supply, Liebergott calculated. At the current leak rate, oxygen Tank 1 would be empty in 2 hours. Kranz ordered an immediate power down, shut off everything, every non-essential system, lights, computers, heaters, guidance, turn Odyssey into a lifeboat, minimal power, buy time. But even with the power down, the math was brutal. They had maybe 3 hours of oxygen left in the command module. Then, nothing. Lovell made the call. We're going to have to go to the LM, Aquarius, their lifeboat, their only chance. Now, the lunar module was never designed for this. Aquarius was built to support 2 astronauts for 40 hours. Land on the moon. Walk around. Take off. Rendezvous with Odyssey. Not support 3 men for 4 days. But it had one critical advantage. Independent systems. Its own power. Its own oxygen. Its own engine. Haise and Lovell floated through the docking tunnel into Aquarius. They powered up the systems. Guidance computer, online, life support, online, communication, online. The LM came alive. Swigert stayed in Odyssey, shutting down every system except minimal radio. Within 2 hours, Odyssey was cold, dark, silent, a tomb drifting through space. Now all 3 crew members were in Aquarius, a spacecraft designed for 2. For 2 days. They needed it for 3 people. For 4 days. Well, the first crisis hit within hours. Carbon dioxide. You see, every breath humans take produces CO2. Normally, lithium hydroxide canisters scrub CO2 from the air. The lunar module had LiOH canisters, but only enough for 2 people. For 2 days, engineers in Houston did the math. With 3 people, the CO2 would reach toxic levels in less than 24 hours. The crew would suffocate. But wait. Odyssey, the command module, had LiOH canisters too. Plenty of them. Problem? Command module canisters were square. Lunar module receptacles were round. You cannot fit a square canister into a round hole. Now, engineer Ed Smiley gathered his team in a conference room. He dumped a box onto the table. This is what we have on the spacecraft. Period. We have to make this. He held up a square canister. Fit into the hole for this. He held up a round receptacle. Using nothing but what's on board. The team got to work. They had materials on the spacecraft. Duct tape, plastic bags, cardboard from the flight plan covers, hoses, socks. Yes, socks. Within hours, they had a design. They radioed the instructions to the crew, step by step, using materials from the spacecraft. Swigert and Haise built the adapter. A square command module canister, taped to a plastic bag, connected to a hose, sealed with duct tape. A lot of duct tape. It looked ridiculous, but it worked. The CO2 levels stabilized, then dropped. The crew could breathe. Duct tape and ingenuity had just saved 3 lives. They had oxygen. They had power. But they were still on the wrong trajectory. The explosion had pushed Apollo 13 off the free return path. Not by much, but enough. If they did nothing, they would miss Earth by 60 miles. In space, 60 miles might as well be 1,000,000. They needed a course correction. Now, normally, course corrections used the primary guidance and navigation system, a computer. Accurate, reliable. But the PGNS was in Odyssey, powered down, to save electricity. They couldn't risk powering it back up. Not yet. So they had to use the lunar module's guidance system and steer manually, using the Earth as their reference point. The burn was scheduled for 61 hours into the mission. They had 1 shot. Lovell aligned the spacecraft. He put the Earth in the window, center of the reticle. Haise called out numbers, velocity, angle, time. Swigert monitored the engine. Lovell fired the LM descent engine. 14 seconds. Manual control. No computer. The engine shut off. They waited. Houston checked the telemetry. Trajectory nominal. They were coming home, but survival was far from certain. You see, Aquarius was freezing. The crew had shut down every non-essential system to conserve power. That included heaters. The temperature inside the lunar module dropped to 38 degrees Fahrenheit, just above freezing. Condensation formed on every surface: walls, windows, instruments. Water droplets floated in zero gravity. The crew wore every piece of clothing they had: flight suits, long underwear, boots. They shivered constantly. Fred Haise developed a kidney infection. Fever, pain, no medicine, no way to treat it. He endured. They rationed water, 6 ounces per person per day, for 4 days. Severe dehydration. They didn't sleep. Not really. Too cold, too stressed. Lovell lost 14 pounds. Haise lost 15. Swigert lost 12. And they had one final challenge ahead: re-entry. To survive re-entry, they needed Odyssey, the command module, the one with the heat shield. Aquarius couldn't re-enter. It had no heat shield. It would burn up. So the crew had to power up Odyssey, transfer back, separate from Aquarius, and survive the plunge through Earth's atmosphere. But Odyssey had been powered down for 4 days. Cold. Dead. Could they bring it back to life? Normally, powering up the command module took 3 hours. with full ground support. With ample electrical power, they had 45 minutes and minimal battery power. One mistake, and they'd lose guidance, or communication, or life support. Now, Ken Mattingly, the astronaut who'd been pulled from the mission, worked in the simulator in Houston. He developed a procedure, step by step, every switch, every circuit breaker, in the correct order. Minimal power draw. He radioed the procedure to the crew. Swigert copied it down, dozens of steps. Then he executed, switch by switch, circuit breaker by circuit breaker. The command module came alive. Guidance computer, online. Communication, online. Life support, online. It worked, but now they had a new problem. The heat shield. Remember, the service module was damaged. That entire panel blown off. Was the heat shield damaged too? The heat shield was attached to the base of the command module, right next to the service module. If the explosion had cracked the heat shield, even slightly, they would burn up during re-entry. There was no way to inspect it. Not in space. They would only know when they hit the atmosphere. At 142 hours into the mission, Lovell separated the service module. He maneuvered Odyssey to get a visual. For the first time, they saw the full extent of the damage. An entire side of the service module was gone. Twisted metal, exposed tanks, wiring hanging into space. It looked like it had been hit by a missile. Lovell snapped photographs. For the investigators. For the engineers. Then he let the service module drift away. Next, they separated from Aquarius, their lifeboat, their savior. It had kept them alive for 4 days. Lovell radioed a farewell. Farewell, Aquarius, and we thank you. The lunar module drifted away. Hours later, it burned up in Earth's atmosphere. A shooting star. Now only Odyssey remained, falling toward Earth, at 25,000 miles per hour. Re-entry blackout would last 4 minutes. During blackout, the superheated plasma surrounding the spacecraft would block all radio communication. 4 minutes of silence. If the heat shield failed, mission control would never know. The crew would simply not respond. At 142 hours, 40 minutes into the mission, Odyssey hit the atmosphere. The heat shield glowed orange, then white, 3,000 degrees Fahrenheit. Inside, the crew felt the G-forces, 4 times Earth's gravity. They waited. Blackout began. Mission control waited. The world waited. 4 minutes. 4 minutes. Silence. 4 minutes passed. 5 minutes. 6 minutes. Mission control was silent. Gene Kranz stared at his console, waiting. Then, a voice, faint, through static. "Okay, Joe." It was Jack Swigert. Mission control erupted in cheers. They were alive. Seconds later, 3 red and white parachutes blossomed above Odyssey. Main chutes deployed. The capsule descended, gently, toward the Pacific Ocean. At 142 hours, 54 minutes, 41 seconds, Odyssey splashed down, 1.4 miles from the recovery ship, USS Iwo Jima. Navy divers jumped from helicopters. They secured flotation collars around Odyssey. They opened the hatch. Lovell emerged first, exhausted, dehydrated, but grinning. Then Haise, pale, weak from his kidney infection. Then Swigert, squinting in the sunlight. They'd been in space for 6 days. They hadn't showered, hadn't slept properly, hadn't eaten full meals. They'd survived an explosion that should have killed them. They'd lived in a spacecraft designed for 2 men. They'd stretched consumables beyond all engineering limits. And they'd survived. Now, the investigation took months. Engineers determined the cause. Oxygen tank number 2. A damaged wire. Insulation had been scraped off during manufacturing. When Swigert flipped that switch, the wire sparked. The insulation caught fire. The tank ruptured. One wire, one spark. Nearly killed 3 astronauts 200,000 miles from Earth. NASA redesigned the oxygen tanks. They added redundant systems. They improved procedures. Apollo 13 was called a successful failure. They didn't land on the moon, but they brought the crew home alive. Jim Lovell never flew in space again. Apollo 13 was his 4th and final mission. Fred Haise flew on the Space Shuttle approach and landing tests, but never in space again. Jack Swigert became a U.S. congressman. He died in 1982. Gene Kranz retired from NASA in 1994. He kept a small plaque in his office. It read, "Failure is not an option." That phrase, it was never said during Apollo 13. It came from the movie, but it captured the spirit. Because on April 17, 1970, failure truly was not an option. And because of that, 3 men came home. This has been Edge of Disaster. Thank you for listening.